How many days left? I mean, look at that. Oh, and by the way, May the 4th be with you. That's Star Wars Day. Had to put that on the calendar. Then look at this. Isn't that exciting to see that? All the children throwing their papers up in the air. There is a class in here. I know there was no reaction to that. But anyway, don't worry about it. Okay. Oh, and I didn't take attendance. Oh, darn it. Oh, well, we'll wait. Okay. Oh, don't you love being first in the alphabet? Well, too bad. Okay, so hey, Ali. Ooh, his name got said. I won't say your last name, then you could sue me. Um, what's more complicated, the left side or the right side? That's funny. You're the first person to say that. I'm gonna say correct because most people said the right side because of fractions. Now, Ali, we are gonna think. You don't do this now. This is your brain. Don't touch your pen. But I'm going to ask you this, then I move on to Lucas. And I hope I get everyone's name right. Again, I said that at the beginning. I have a hard time with these masks and remembering everybody's name. It's just been a bad year for that. But Ali, what's 1 minus sine squared? Uh-oh, you're looking at that identity sheet. You got to have this memorized, my friend. What's 1 minus sine squared? We're waiting for him. Lucas, can you help him and then you be done? Oh, he's getting his formula sheet out. Antonio, do you remember what 1 minus sine squared is? Oh my goodness. Modest, do you know what 1 minus sine squared is? I quit. The whole first row doesn't know what 1 minus sine squared is, and this was already on a formula test. Lucas? Oh no. It's the what? You see what I'm dealing with teaching high school, all right? So, what's 1 minus sine squared, everybody? No, I got you. You're right. Okay, but what's 1 minus? Got you. Ali, did you find it yet? Lucas, did you find? I don't care that this is on the video. This is what I'm dealing with right now. And to anyone in that first row, can you tell me what 1 minus sine squared is? He's not in the first row. It's cosine squared. All right, back to you, Ali. Do not write this, but tell me what is 1 over cosine squared? Lucas, do you know what 1 over cosine squared is? Antonio, do you know what 1 over cosine squared is? Modest, do you know what 1 over cosine squared is? Secant squared. We got somebody in the first row. All right, so now don't write all this down, but do you see, Ali, why the right side is not more complicated? It's hard, everyone else, to turn secant squared into the left side. It's hard to grow that. It's easier to condense. So, Ali, you are correct. The left side is more complicated than the right. All right, let's move on. Ali, what is 1 plus cotangent squared then? Or we'll go through the rest of the row and get that figured out. You are copying that off of that sheet. I'm telling you right now that you will not have that in front of you. You have to somehow get this memorized. Make flashcards. I don't know what it's going to take, but do something about that. Lucas, now I'm going to do something, not nothing. What's tangent squared? What's cosecant squared? We're going to change those two things. I'll give you a hint, it's a fraction, and I don't want 1 over cotangent squared. So I pretty much told you what I want you to write for tangent squared. Antonio, do you know what tangent squared is? Modest, do you know what tangent squared is? Oh my gosh, what is going on with this? We got to move out of the first row and go to the next row. All right. Oh, the new girl. Oh my gosh, I lost your name. It's Julia? Julia? Yeah, new girl, but like 5 months ago. But anyway, sorry. Julia, what's tangent squared so we can get this first row taken care of here? But sine what? Okay, and then back to Luke. Ali, you're done. Okay, so woohoo. All right, Lucas, you're not. So then what am I looking for cosecant squared? What is that? Here, I'll give you a hint. I'm looking for 1 over. At this point, just look at the formula sheet. I'm going to cry here. What is cosecant squared? 1 over what? This is from chapter 1. Sine squared. Okay, and then Antonio, who cancels? And then Modest, what is 1 over cosine squared? Stop! Look at the right side. Don't tell me what 1 over cosine squared is. Tell me what is cosine squared. Look at the right and then look at the colors of the highlighting. So that is what you write as a structure. You are telling me that you know, yes, cosine squared is 1 minus sine squared. That is the logic. That's why I don't want you to write reasons on the right like the other teachers are writing, because I don't need that. That's what you're telling me. You were telling me you know that, and therefore I've nailed it and got the left side equal the right side. Sorry about that, Julia. That was just a block there. She's mad at me for not remembering her name. Okay, now I will say this. Now we're going to move on and do more identities, and the structure should look like that. Some people are snaking their work and it's all over the place. I'll tell you another thing where you're going to get wrong answers, or I'm going to mark you wrong. Not writing X there, that's sloppy. You don't sine squared error. You need a variable there. All these things need to be cleaned up. But structure, in every step, there's one change for each thing. So I can logically see, yes, that makes sense. Yes, that makes sense. And so on and so on and so forth. And I'm telling you right now, I can't help anyone that cannot memorize. If you cannot memorize 5.1, you're done. All right. There's nothing I can do to get you to memorize that. As a matter of fact, I'm going to have one little quick matching of having these in there as well. And I don't think that's unreasonable. I know that's a double negative. I don't care. This is in English. So if you're doing your homework, you should know that cosine is cosine, cosine, sine, sine, right? Homework doers. And the signs are what? Same or different? Different. Here are the people that do homework. And then sine, the signs are the same, and sine is sine, cosine, right? And then tan, come on. The numerator, the sign is the same. And then it goes opposite on the bottom. Okay, and then after we're done with the formula matching, and then the matching, like doing a couple steps on simplifying, then we move to a written test, and then I'll give you this formula sheet, and then it's usage. And then when you have that formula sheet in front of you, this is one of the questions you might have. Woo! And notice what it says. It says verify. Each equation is an identity, so it's the same process. Now, Lucas, you've already done a few things for the first row, so you're good, okay? You've accomplished doing something for the class here today. So, Nadia, which side's more complicated? Oh, by far, right? I mean, and again, it's the idea of big to small is easier than small to big. It's hard to make things go. That's why Ali picked the right thing about the last one. The left side was actually more complicated to get it turned into the right. Okay, here we go, Nadia. Whoops. What is that? Because CAT students do something, not nothing. So when I look at that after I saw Monday's lesson, what can I turn that into? Good? Oh, that's not the rule. Sine x, sine, wait. What sine? What's the sine rule? Sine, then what? Okay, let's look up here. Sine sum rule. That's what we're emulating, but we got different variables. Okay, so what do we got? Sine x, what's next? Oh, okay, there's no plus sign here. This says sine A, then what? Where are we looking at? What's going on? Am I in a twilight zone here? What is happening in seventh hour? Okay, what does that say right there? What operation is? I'm about to strangle myself with this cord. Multiplication. So let's go back to this. You guys even know what the twilight zone is? Anyway, sine x, then what? Okay, let's go back up. What does this say right here? Okay, so let's go back. Sine x, what? Cos y. And then what's next? I can't wait to hear this one. What's next? Signs are the same. And then what's next? Now don't just copy that formula. That's what I do. I do sine y cosine x. This is fun. All right, Blanca, are you ready? This is just going great so far. She goes, okay. All right. Now you're going to do the blue. And you don't need a highlighter. I'm for note purposes. Okay. This isn't hard. It does take some space. All right. And now we're going to do the blue. So what's that one? Sine X, cosine Y. And then what? Minus. Good. Signs are the same. And then what? You're done. Now we're moving. And then you do something, not nothing. Okay, fine. I got that. Alyssa, are you ready? Okay, now. Oh, let me highlight this in blue. What should you mark on this step right here? What happens as you look at these things? I can combine, but also I want to what? There's another cancel. Who cancels? That's what I want to do on this row and then combine. Yeah, and you said it in reverse. In case it was reversed, they would be, she said, the cosine x sine y. That's okay. Commutative property. You understand if they were reversed, they still would be opposites of each other. These are exactly the same terms, so they should cancel. And then she already said combine, so I think this is what you meant, right? And then are you done or not done? You're done. This is ridiculous. It was only really one step and then writing the next step of combining the like terms. So again, understand that you write it, it is something equal to itself again, because logically you're telling me from step 1 to step 2 that that does equal that. And then you go, oh yeah, that equals the other side. And then you draw the arrow. You don't do that, you're gone. Okay? I'm going to get you. Oh no. Okay, where are we at? The other new girl, Veronica. Where you go? That's it? She's had enough. Anyone else want to leave? Okay, I know. Well, you're already done. You don't have to answer any more questions, so you're off the hook. Veronica, we do something, not nothing. I'm going to skip a step here, or I'm going to go down here just because of space. So what would that be? Now, she's getting her formula sheet. Should I yell at her, yes or no? No, because on the test, are you going to have the formula sheet in front of you? Yes. Okay, so go ahead. Emulate A and B on your formula sheet. So sine A plus B, right? Then what? Good. And then what? Good. And good, you are doing what I do. You're not reading right off of the formula sheet. You're saying, okay, then the next part is sine of the other angle, cosine of the other angle, switching the angles. That's the way I like organizing it as well. Good. And then Kevin, honestly, this is what we got to do with that minus sign. Whatever I write after this minus sign, I'm telling the next person that minus sign needs to be distributed. But your job is to tell me what this is. Nope. Look at the formula again. There's no plus. You did a Nadia. Sine x. Sorry. Oh, I'm sorry. Remember, cosine is cosine, cosine, sine, sine. So what should be after cosine 120? And then what's the sign here? Is it plus or minus? Minus. Cosine, the signs are not the same. And then what do I write next? And then, unfortunately, but not unfortunately, because you know your chapter 3, don't you, Lindsay? Now you are charged with how do I evaluate these? Now this is a little different than the other ones. Okay, so you set up the next two guys. Okay, what's 210? I don't want this in the structure of the proof. But so off to the side, what's 210? Is it a 30 or a 60 reference angle? It's a 30. You know why? Because it's 180 plus 30. It's 30 past 180. And then what quadrant is 210 in? Third. And then set up the next one too. What's 120? Is that a 30 or a 60? And what quadrant is that in? Second. And now you set up John to do the trig of 210. Hey, John, I think I've heard myself ask this quite a bit. What's sine of a 30? Right, everyone? Okay, what's sine of a 30? 1/2. Stop, though. What's sine in quadrant 3? Positive or negative? So you put a negative 1/2 here, and then cosine of x stays, and then sine of x, and then John, still keep going with the 210. What's the cosine of 210 then? And it is negative, and it's the other ratio, negative root 3 over 2. So that's why it starts with sine of a 30 is a half. Therefore, cosine of a 30 is root 3 over 2. Sorry if that's a messy 3 there. We should know that, though. And then Jeremy, we're still going to keep this minus bracket because I really want to take care of what's going on in the brackets first, then distribute the minus sign. You know what I'm going to do? I'm going to go to sine first. Remember what John said, sine of a 30 is a half. So what does that mean sine of a 60 is? Root who over 2? I thought I heard something weird there. Root what over 2? I can't quite hear you. That's what I thought I heard. And then what is sine in quadrant 2? Is it positive or negative? Oh, all students take calculus. Students in quadrant 2 means what's positive in quadrant 2? No. Well, yeah, but also what starts with S in trig? Sine. So sine's positive in quadrant 2. And then what's the cosine of 60? And it is negative because cosine is negative in quadrant 2. Well said. Okay, and then we got a minus sign, and then this is something that can't be evaluated, so I just have to write it. Don't tell me this is hard. Okay, and if it is hard, it's because we still don't know chapter 3, and I'm upset about that. All right, and you're just emulating a formula on the previous step. Sorry, step 1, step 2. All right, and then I'm going to do this for you. Who's next? Okay, so I always get you two mixed up for some reason. This is terrible. I couldn't. Okay, hold on. And I just had you come in yesterday. This is bad. Oh my gosh, mind lock. Wait till you're a teacher. And I know I do that every day. You like horses, right? Remember that? And the picture has first letter E. Elizabeth Snyder. Oh no, you can sue me now. I said your last name. Go ahead. I don't have any money anyway. It doesn't matter. Okay. Sorry, Elizabeth. Let's get this distributed. Oh, what the heck? See, even look at this. Now the computer's going against me. All right, here we go. So step 3, negative a half, cosine x. You know what? We got to clean this up. This should actually be written in front. This should be written in front. And then this becomes a positive. This is why I waited. Because otherwise you're going to jack up like what the signs are. If you start, it's a possibility anyway. And then Elizabeth, tell me what happens. Boom. And then what else? But you say cancel. What do they cancel to become when you're adding? Like what's the number left over? 0. So because sometimes people cancel with fractions and they say fractions cancel to 0. No, fractions, something over itself cancels to 1. But in this turns into nothing. And then look, that's what was on the other side. Right? Right. Should I leave that there? We good? Adri? You don't do nothing, you do something. Who's more complicated, left or right? Left for sure. And give you a second to write this down, but also I'm going to write step 1. What is the numerator after you write this question down? We'll wait. 5, 4, 3, 2, 1. Love writing it that way. That means you're not just copying the formula, you got it like locked in your brain. Now, you do something, not nothing. So, okay, fine. He's taught me or showed me these new sum rules and difference rules. So I'm going to use the sum rule and just see what happens. That's what I mean about don't do nothing, do something. Joe, right? You don't know this, okay? But I have had written this in the notes before. When you have fractions, sometimes a valuable thing to do is to split this up using what I call the reverse of the common denominator rule. Because, Joe, look at the right side. You have something plus something else separated, right? I mean, I could turn these both into fractions, but they are separated. So I'm going to turn this into a separated addition statement. And this is the reverse of the common denominator rule, and this is perfectly and totally normal. It is at least equal, let's say. And then, Joe, the easy question I have for you is, in the first fraction, who cancels? Cosine t's, and then the second fraction, who cancels? The cosine s. And now we can move on to Emily. What is this? Sine of s over cosine of s. By the way, look at the right side. But anyway, go ahead. What's sine of s over cosine of s? Tan of what? Did you say s? That's all I was looking for is s. Okay. And then what is this equal to? Tan t. And then are we done? Yes, we are. Okay. So that's all you got to do about that. So Elizabeth, I don't know what this brain lock is. You're always first in my class. I lost it. What first letter? Abigail. Abigail. Okay. Sorry about that. So bad. I feel terrible about myself. My brain's going away. It's like, oh, okay. We don't do nothing. We do what, everybody? Something. Okay. This is the last one that we do, and then we'll do our. You can go ahead and get to work on stuff here. So yeah, some time to do work in class. Okay, Abigail, this is gonna be, trying to remember from doing your homework. What's tan of x minus y? First of all, it's a fraction. What's up in the numerator? And then what? And then what do we have on the denominator? Oh, so one what? And then what? And it's times there, but you don't have to say that. Okay, so up in the numerator it's a subtraction, then it's 1 plus on the bottom, tan x, tan y multiplication. And then, I guess I ran out of students, so Julia, you'll be the last one here. What's this one? Let me highlight this, that's the yellow. Certainly don't bring a highlighter, and I'm just doing this for no purposes. Tell me what that one is. By the way, I'm sorry. This should be in brackets, because whatever I write in here, I should be subtracting. And will write what you said there. Tan y minus tan x. Okay, and then my next question is, I guess I ran out of students, so I'm all by myself on this one. Where do I distribute that minus sign? Is it the top? Is it the bottom? Or is it both? Don't say both, because what's a negative over a negative, everyone? Positive. If you distributed a minus sign to both, then you literally turn that into a plus sign, just mathematically. So it's either or, but I'm going to distribute it to the numerator. And then I'm going to use, I don't know why I'm walking around, it makes it tough to write. I'm going to use the common denominator rule the correct way, not the correct way, but I have a common denominator, right? Aren't those denominators exactly the same? So therefore, I will write this as adding the numerator and putting it over a common denominator. Why? Look at the right side. It's all about the right side and trying to match it. And now I have the right side's denominator. Am I right or am I wrong? Of course I'm right. Okay, so now tan of x minus tan y. Wish I had more students. Maybe we'll go back to Ali. How about that, Ali? Would you want to go? Let's do it. It's fun. Okay, so, and then this becomes a plus, right, Ali? We'll get that first row because of how the class started. Okay, so Ali, what's tan x plus tan x? 2 tan x. Lucas, what's minus tan y minus another tan y? I couldn't quite hear you. So it's not 2 minus tan y. I think you just switch those. It's minus 2y, 2 tan y, right? And then Antonio, let me get this finished off here. What should I do with the 2 in the numerator? Starts with an F. F-A. Good blankers are good foilers. What's the word? Factor. Sorry, that Y looks like a 4. This Y is a Y, not a 4. And then Modest, you actually did do it. So Antonio, are we done? Look at the right side. Are we done? Are we done? Yes, we're done because you have written that the right side is exactly to the left. So I wanted to exercise these identities in up with the sum and difference identities, I mean, and proving identities, but also to hammer down what your structure needs to look like. Your structure has got to get better overall, that it is nice and neat and structurally one step at a time building to the end. Okay, and hopefully we see that on Friday because I do want to see you do well. Alrighty then, we'll start passing back those papers. I'll end this. Ooh, there's the calendar again. Good to see that we're getting close